This video is going to go over the commutative, associative, and distributive properties of operations that we need to focus on this week. We will, for each property, you'll have a set of words, you'll have pictures, and you'll have examples. So you'll be able to wrap your head around this, hopefully, in many ways, and then that kind of helps your brain lock in to these different properties. So for commutative, I always think about this first two letters of commutative, CO, and I always just think change order. So if everything else fails that you can't remember commutative, I always think change order. So you change the order of the addends or factors, and then you still obviously get the same answer. So in words, we can say the commutative property states that the order of the numbers in an addition or multiplication expression can change, and then that doesn't change the answer of the expression. So a picture of these things would be here. 6 plus 3 is equal to 9, which is also equal to 3 plus 6. So it doesn't really matter the order in which you add these things, you're still going to get 9. Same thing, you can have 4 groups of 2, or you can have 2 groups of 4. Either way, you have 8 objects. So we're looking at this graphic here. It says, for multiplication and addition, this cartoon says, so you two work from home, huh? And the subtraction says, quite. And the division says, we really don't like to commute. So you have to remember that multiplication and addition are commutative, but you cannot commute subtraction or division. Real life examples might include something like putting your left sock on, then your right sock. Or you can put your right sock on, then your left sock. It doesn't really matter. You can accomplish putting both of your socks on in either order. So that's commutative. Something that's not commutative would be to put your jacket on after your shirt or putting your shirt on after your jacket. That doesn't really make sense because you don't want to put a shirt on after you put your jacket on. So that's not commutative. Some examples here, commutative property of addition. You can show this in symbols. Sometimes you'll see that part of the expression is not changed. So in this case, 64 plus this quantity, 2x plus 6, is equal to 64 plus, then in the quantity you see there's commutative property of addition happening. So we switch the 6 and then the 2x. Those two terms get switched there. And then here's some other examples here as well. 4 plus AB is equal to AB plus 4. Sure, you can come up with your own examples as well. For multiplication, A times B times C times D is going to be the same as B times A times C times D. You can rewrite these 4 factors in any which order, and they will end up being the same product when you're finished. Here's a funky one. You have 4 times this quantity, and inside the quantity, things do not change, but the 4 is switched, so the factors are changed. So the first factor here is 4, the second factor is x plus 1, and then on the other side of the equation you have x plus 1 times 4 instead. Either way, you can distribute this 4 into the quantity, or multiply the quantities if you know the value for x, and then you would get the same result. Associative. So if you think about associating, people associating with each other, usually they associate in groups. And so I always think about this as regrouping, regrouped. The associative property states that the grouping of the numbers in an addition or multiplication expression can change, but the order doesn't change. And that says numbers. They could be any type of term in an addition expression or any type of factor in a multiplication expression. It was easier just to write numbers there. Okay, so this is a little bit funky, but here's a picture of what the associative property would look like. So if you had 5 groups of 2. Here's the 5 groups of 2. Okay, and we had it 3 times, right? So essentially 3 groups of 5 groups of 2. Here, 3 groups of 5 groups of 2. So this is 5 groups of 2 3 times. Awesome. If you have that multiplication and you set up that array, you could set it up differently. You could say instead of 5 groups of 2 3 times, you could say 5 groups of 2 groups of 3. Or you could say 2 groups of 3 5 times. But we want to maintain that 5 in the front so that we don't change the order. In any case, 5 times 2, that answer times 3, is going to be the same as 2 times 3, that answer times 5. Either way, if you count up all the dots, you're going to get the same answer, which 5 times 2 is 10, and then times 3 is 30. So the answer is 30 for both of these. 5 times 6 is 30 as well. Okay, so here's another picture. So you have a little more of a visual real-life example. So you have the two people, A and B, who are associating together. And then you have C there on the other side, just A plus B in parentheses, they're associating. And then A is by itself, and then B plus C are associating together. So it just gives you another little visual there. Okay, real-life example. So you have friends at a movie. Adrian and Benji sit next to each other with popcorn in the next seat, and then Carl is by himself. And then after the previews, Adrian sits alone, and then there's popcorn in the middle, and then Benji sits next to Carl. So you have Adrian and Benji associating together, or you can have Benji and Carl associating together. But either way, Adrian, Benji, and Carl are all at the movies together, regardless. So that's where I kind of use the ABC here. This is what it would look like if it was in symbols. Let's see. Yeah, so this is an example here that I really like to emphasize with my students. 6 plus 1 plus 4. If there's no parentheses, you can add parentheses, and because there's no grouping, you can regroup all of those terms together in one big group. You can group the 6 plus 1 and then leave the 4 out. You could group the 1 plus 4 and leave the 6 out. As long as you have 6 plus 1 plus 4, 6 plus 1 plus 4, 6 plus 1 plus 4, 6 plus 1 plus 4. As long as it's in the same order, you can regroup by rewriting or adding or taking out the grouping symbols, which is parentheses or brackets. And then that way you're using the associative property. And then here's just some examples with a negative. Get your mind wrapped around that too. For the associative property of multiplication, you can do the same exact thing. So if you have no parentheses, you can add parentheses in. If there's parentheses, you can take parentheses out. You can associate two factors, 1/2 times b together. You can associate bh together as long as you keep the same order. Okay, here's a common error. Just because you see parentheses doesn't automatically make it associative. So that's where one thing I feel like you get trained, because you think, okay, grouping symbols, associative, awesome. So if I see grouping symbols, it's going to be associative. Just make sure you're not giving yourself a rigid mindset on that. Just make sure you're looking for regrouping or looking for other evidence of properties before you make assumptions. Okay, last one for this video, distributive. A product of the sum is equal to the sum of the products. The distributive property states that when a number is multiplied by a sum or difference, you multiply it by each term in the parentheses, or you multiply it by each thing in the parentheses. Okay? So this is a little bit difficult to wrap your mind around verbally, but if you keep going back to this, a product of the sum is equal to the sum of the products. And I'm going to show you what I mean by that. Okay. So a classic picture, a classic example would be if you went and got some value meals somewhere and you got 3 meals, so you get 3 bags, right? So in each group, in each bag, so you have 3 groups of, and all 3 people got the same exact meal. So you say, okay, well, when you get a meal, you're going to get a drink and you're going to get fries and you're going to get a burger in this case, right? So you would have 3 meals. Therefore, you would have 3 of each item in the group. So 3 groups, you'll have 3 of each item in the group. So you're going to have 3 drinks, 3 fries, 3 burgers in this specific case. Let's look at some more examples. So here we go. This is an algebraic example. So D represents drinks, F represents fries, B represents burger. So there's 3 meals. And then in this we're going to use these parentheses to show grouping. So 3 groups of this sum, okay, so a product of a sum is equal to the sum of all the products individually. So you take 3, there's 3 drinks, 3 fries, 3 burgers. So you have 3 drinks and 3 fries and 3 burgers. Okay, this one's a little bit funky, so I decided to keep this example so that you can kind of see this is a kind of a left field example. If you have a negative quantity, so you have a negative outside parentheses, there's actually a 1 in there. So you can use the distributive property and say, okay, well, if this is the opposite of the sum, this is -1 times this entire sum, then I can multiply each of the items in the parentheses by -1. So then I just have -1 times 2 is -2. -1 times x is -x. Okay, careful here, careful here. This is like the main number one mistake that people make with distributive property is dealing with the 5 here. So you have 5 minus 2 times the quantity x minus 6 minus 4x. There's a lot going on here. And your brain is going to want to do something with this 5, maybe do something with this 4x, but you have to start looking at each of these components individually. And don't let your brain run away from this. So we keep the 5 exactly the same because the 5 is just a term out in front of the expression. And what's happening here is you're taking away 2 times everything in this group. So you have -2x. So you're going to take this -2 and you're going to multiply by x. So -2 times x is -2x. You're going to take this -2 and you're going to multiply by -6. -2 times -6 is +12. And then the -4x here is just an extra term. It's not in the parentheses, so we don't want to do anything to it, so we leave it as it is, -4x. So just be very, very careful with these examples. It'll come up again and again. So I would just somehow, I don't know, write this down, ask me questions if you're not sure about the examples, and then I would just find a way to catch yourself or to double check before you just start doing the problems, because I feel like, you know, you start doing some problems, you get into a flow, and then you just do it, and then you kind of don't realize that you're doing it wrong. So that's it. So you have commutative property, which is change order of terms or factors. You have associative property, which is regrouping using grouping symbols, brackets or parentheses. And then you have the distributive property, which means that the product of a sum or difference is equal to the product of each individual term in the sum or difference.